GigaMe Instructor Live Sessions. Today we take a session on essential algorithms and data structures.
Hi Abhinaya, how are you?
Yeah, good. How are you?
I'm good too. Okay, so an interview happened?
It's tomorrow.
Acha, 2 to 14 is my end. Okay, yeah. Because I'm waiting for this interview.
Hmm.
Yeah, so how is the preparation going on?
Yeah, okay. But it was difficult to cover all the topics in 2 weeks, right?
Yeah, I know. But still, no, you have more than that had because we were talking about this interview, I believe, mid of February or 20th of February.
Yeah, even if you say 3 weeks, that is not enough to do all LeetCode media.
Yeah, but फिर भी something you must have done na, and you have
Yeah,
also
something
practiced a
I
lot.
have done, like array, strings,
No, you
and
have practiced a lot as well for the business logics and all everything.
it, it's not business logic thing. See,
Liquid.
if they ask API and stuff, that I can do. This is
Mhm.
LeetCode medium.
I know.
Yeah, I
So
have hardly done 15 programs in LeetCode.
in array only?
No. So I did some sliding window, then 2 pointers. Then yesterday I was doing some trees. Then I meant to do graphs, but I know like how to do BFS, TFS, just the basic.
Okay. Okay.
Mhm.
Fine.
So I need
Um,
to do dynamic programming, and then
mhm.
not enough. 3 weeks is definitely not enough because I
No,
was also
yes.
preparing for just for that C sharp.
Yeah, even the lead code is going to take a lot. Sometimes, in the starting, one person can only solve one lead code in 2 days.
Yeah,
3 days.
that's also there. So I actually get closer to the implementation, then something will happen. You will waste time. So today I was doing it's a very simple problem, I would say, like level order traversal. But you have to return the result array as subarrays.
Mm-hmm.
So my implementation was right, but I was giving wrong input without creating nodes on my VS Code. So I was getting all wrong outputs and it was not working. So I was doing it for at least for like 2 hours, more than that.
Okay. Yeah, and it is very frustrating as well.
Yeah. So now I was just looking for some basic programs like palindrome, anagram.
Okay. With which company you have interview?
This is Geico.
Okay.
It is backend. The role is actually mainly backend. They need someone who has experience with microservices, .NET Core and stuff, MongoDB, etc. But I don't know why they need to ask LeetCode for the coding interview.
Hmm.
I'll not be doing any data structures.
Mm-hmm. I was just going through a few of the problems, like liquid lead code problems, right?
Yeah, but can you tell me all basics, like all the algorithms? Just
Okay.
like,
Revision sort of thing you want to do?
yeah.
Okay. So in in array, and then in have
So
you done
I
binary
will
search
tell.
tree?
I didn't do binary search tree, but I did binary trees. Uh, so there just the basics like how to do DFS, BFS. So now I know you need to use stack for DFS and queue for BFS. How do you DQ or pop and how you read values? All those things I
Okay.
know. I can code for it. Then I did some tree sum.
Mm-hmm.
but I cannot do like some minimal ancestor, something like that. Those are all bit advanced, I feel. Maybe I'll be able to do it, but I did not check those now. Sometimes they'll ask very simple question and we'll be fixated on all like higher algorithms and just waste your time.
Yeah. Actually, this happened with one of my learner.
Hmm.
They asked a very simple thing, and she, because it is always in our mind, if very good company is asking any question, there might be something in the question. That's why they're asking,
Hmm.
right?
Hmm.
Otherwise, he asked a very simple question of just one line question, and she thought that something else is also theirs, and she took 10 minutes to give the answer.
Hmm.
So I also say that don't, if you think that, just take a pause and just think about the question. If you think no, it's pretty straightforward, then give the answer. Otherwise, you can also ask them, ki, you just want me to like have this and that. That's it. You can also counter question, na?
Yeah,
Ki,
yeah.
yeah, that whether you are having, oh, this is the only scenario, or you are putting any constraint or something like that,
Hmm.
right? So that you can be more specific or general about the question.
I'm sure I cannot do graph and tree if it's all advanced question if they ask. I can try doing like BFS, TFS. So yesterday I picked a problem,
Hmm.
grid traveler question in dynamic programming, that you need to represent it as like matrix, adjacency matrix, or
Hmm.
graph,
Okay.
and then you need to find the uh, path, like smallest path, something like that.
Yeah, yeah. Sometimes it is Kruskal's
Yeah,
algorithm.
you have
Yeah.
two rows. You
Mm-hmm.
start at one point, end at one point. So you'll keep adding everything. Like first row, first column, second row, second column. You just keep adding until the end, and then find the minimum of all of these things. This is dynamic programming. But to find out its dynamic programming itself will take time
Okay.
from the question.
Correct.
Hmm. I need time. I at least need like 3 months if I need to get good hold of LeetCode. If I'm doing just LeetCode. I
Still,
also
I don't
did.
think so. Yeah, it takes like easily to have a very good hands-on for lead code at
But
least.
then I would say I will just be at beginner level. You see, uh, actually, this is good for people who are just out of university because they'll be doing only this in college. Where you
Correct.
ask, like, after 7 years, 8 years, why do you want me to do data structure program? You ask me something from project, you make me do some full stack uh, tiny website or something like that, right? That will be much helpful. Like there you can show, you can integrate cloud, you can do some like faster API. There you can show something. This is bullshit, really.
No, no, but nowadays, what is happening in the interviews? They are, asking the very deeper type of questions, rather than, because see, there is always a difference between a coder and the person who is, learning in college, or let's say who's teaching. Because to coder, if you will ask someone a very deep dive question, that person is never going to give you the answer, because they always know that what to write in the code, right? Because they're very much into the code only, right? They can't explain
Yeah.
things, correct?
Yeah.
But reviewers are asking in the terms of that they have to explain. That's where the problem is coming.
I was typing something. Grass, trees.
Okay. See, let's go topic by topic.
Wait, I'm typing you the topics. You just see. There might be more.
Let's start from the basic as well, and these are also I am going to include in between. I mean, just give me 1 second. Huh? You have written all the topics?
Yeah. I mean, these are the topics I remember. I forgot stack key. Then doubly linked list. I think it is similar to linked list. Something with string. Do you have any other class after this?
Yes.
Okay.
Okay, so Abhinaya, let's start from very basic and let's talk about these. And you just give me the answers on the basis of that. And in your mind, just think that what logic it is going to be, right? Because if
Okay.
you're going to
Yeah.
solve any problem, na, it will take our entire lecture, right?
No,
Okay.
I don't want to solve problems.
No,
Just
yes, that's a revision sort of thing. That's what I'm
yeah,
trying
yeah.
to say.
That's what. See, let's say sorting. I know bubble sort. Then what is I
Wait,
did,
wait. Let's start. Okay, so I'm
but
gonna
I don't
start.
know how. I could not understand insertion sort. I just left it.
Okay.
Then I need to know about merge sort, selection sort, and then radix and one more
Mm-hmm.
bucket
Yeah.
sort.
Bucket sort. Okay. Wait.
I mean, I was asking ChatGPT anyway.
Mm-hmm.
I feel that is useful.
ChatGPT, but doesn't have the information after 2022. It is never
Yeah,
gonna
but
give you
at
the
least these
latest.
things would not have changed, right? Definition for sorting.
Yeah, yeah. In that case, if you're doing this, what you can do, you can ask like 2, 3 AIs this thing.
Okay.
Yeah, because I think Bard has the latest information till the day.
Okay. What is it?
Bard.
Okay.
Okay, let's start. In array, the very basic questions for the LeetCode that can be come, the topics are like searching, like linear search and binary search. Okay, now tell me, what is linear search? It's time complexity and space complexity and the approach.
So if it's linear search, we are going to go element by element.
Mm-hmm.
So I would say time complexity is O of n, where n is the number of elements that we will use.
Mm-hmm.
Then space is also like O of n.
Space is also like O of n. Okay. And what is the approach?
You do a for loop, go from first index to until, I mean, naive solution will be to go till end, but on the moment you find the target, just return from the loop and return the value or index, whatever is asked in the question. So that
Okay.
will help in reducing the time.
Okay. Can we apply linear search on two-dimensional?
Mm,
How much time it is going to take there? The space complexity of linear
That will
search is
be
always
m cross n, right? Like m rows and columns if it's two-dimensional. O of m into n.
mm, okay.
Or, yeah, is that right?
And what is space complexity?
Uh, m plus n.
M plus n. Okay, and for time you said m into n, right?
Yeah.
See, the time complexity is always going to be order of one. Sorry, space complexity. The time complexity is, yes, you are correct in that. In one dimensional, it is order of n. In two dimensional, it is order of m into n. Right. But the space they are going to take, it is always order of one. Because
Okay.
it only uses a few variables to keep the track of the index and the target element. Okay, fine.
Okay.
Okay, now let's talk about the binary search. Okay, can you apply linear search on sorted array or
Yes.
unsorted array?
Yeah.
Both. Okay. Now, yeah, the same thing about the binary. Space complexity, time complexity, what it is, how it works, and which type of array it can work on.
For what? Binary search.
Yes.
So binary search is also like O of n. But we'll be like dividing the array.
Mm-hmm.
So we should first sort the array and then get the median and check if
Mm-hmm.
our target is less than that or greater than that. Based on that, we need to adjust the index. So we'll be doing only half work. So I think it will be like divided by two of the execution time.
So,
But still it will be O of n, right? So 1 by 2 is like constant. So we can just disregard that one.
no, for binary search, it is always going to be log n.
Okay.
Because in binary search, you know that it is always going to, wait, let me show you diagrams. Now see, this is binary search, okay? So it is never going to traverse the entire part. This is where the
Yeah.
partition is going to happen. So either it will like look for the target element, whether it is lesser than or greater than. So it will go accordingly towards this side. Again, it is going to divide this one into two parts. Then again, it will compare, and let's say it is again going into, let's say target element is 5 only, again into this side. Okay, then all these things are left where there is no need for us to do any traversing, right? So
Yeah.
that's where the time is decreasing. And again, when it is going to come here, let's say it is dividing, making this one as a mid part. And here it is getting the element directly at
Okay.
round number third only, let's say. Okay. So that's how
Okay.
the binary search is going to do. That's why the time complexity is also always log of n for binary search.
Okay.
And again, the space complexity is going to be constant order of 1 because they are not taking any additional space to calculate or to do any traversing.
Mm-hmm.
Okay.
Okay.
Now let's talk about the sorting algorithms in array. We have bubble sort. How does it work? And again, the same time complexity, space complexity, and its approach. I mean,
So
technical approach, you need to tell me in the code wise. That's what you're going to do.
for bubble sort, we'll be comparing the adjacent element and we'll go until n. So we'll just compare and we'll keep swapping. That is bubble sort.
Can you repeat again?
You'll be checking with the adjacent element.
Mm-hmm.
Let's say if I'm taking I is equal to 0, then I'll look for I plus 1 and then see if I is less than I plus 1, then I'll be swapping it. Again, you keep doing this until end.
Until end. So let's say you have an array, this array. Let's talk about this array only. Okay. So this is the first one where you are going to compare this with this, then this with this, and so on, right?
Yeah.
Correct. And
Yes.
let's say after 4 things, is it possible in bubble sort that you are always going to get the answer? Do
No.
you, do we have the concept of passes here?
What is passing?
In
So
bubble
here,
sort,
no,
there
we'll be doing one by one, but that doesn't mean the whole array is sorted. So we will have to resort again, right?
correct. That those are the number of passes. So how many number
Okay.
of passes they are always going to take? Okay. So now I'm giving you one example,
Mm-hmm.
very basic one. Let's say 2, 5, 8, 12, 16, 23, 38, 56, 72, and 91. Okay. Let's say this is your array. Because for binary search, your array should be always in the sorted form. Okay. I'm just going to do one change here. I'm going to put 91 here. Okay. And that's it. Okay. And let's make it 99, which is already here. Fine. So that's one. That means only one element is here which is unsorted. So now tell me how many number of passes are required for this one.
From first or just from after 91?
This is the exact array. You have to tell me accordingly.
So 2 and 5 don't have to do anything. Again, 5 and 8, nothing. 8, 12, nothing. 12, 16, nothing. So we need to have a like indicator, right? If it's swapped, then return true, otherwise false. And based on that, we have to run the loop. So next 1691, we are not going to do anything. But Now here 38 and 91, then we'll swap here. Then again 91, 56. So 1, 2, 3, 4. 4 times?
4 times what? Iteration.
Yeah.
Okay, let's say after this iteration, we are comparing this and this. So of course this is less, so it is gonna swap, right? So after
Yes.
that, 38 is gonna come at this place, and 91 again is gonna come at this place. Okay, then it is going to compare 91 and 56. So again, small, so 91 will come to this place. Again, it is going to compare with this. 91 is small to this one, and it will stay here. And I was making this 99, so it is fine. So in between the 91 is gonna adjust itself, right?
Yeah.
Okay, after that, are you going to look again?
No, I think it is all sorted, right?
That's the case of binary, bubble sort. To make sure that there is no swapping, because in this, like traversing, there is at least one swap you have did, right? Again, it is gonna see that whether there is no swapping at all. So one extra pass is always there in all the bubble sorts, just to make sure.
Okay,
Okay,
okay. Okay, we'll have to run it again. Okay, got it.
correct. Yes. Okay, and what is the time
So
complexity?
then can we use like do while, or it should be for? Because if we use do while, it makes sure it always runs at least one iteration, right?
Yeah, but again, it is gonna come back and run again, right?
Okay.
What is the time complexity of this one?
This will be O of n square.
Correct. And space complexity?
That is same, just O of n.
Of 1.
O of 1.
You just
I have a doubt. So we have number
Mhm.
of elements. We'll be storing number of elements, right? So I thought it is also O of n. Why is it
No,
O of 1?
in
Because
most of
it's
the
just
cases,
constant.
yes, in most of the cases, what you're doing,
It will not be
you are
moving.
just taking their own space to swap each other.
Mm-hmm.
Except this entire space, are you taking anything else?
No.
The space is always there, right? So you are
Yeah.
not taking any extra space. So that means that's already which space they are already having the same constant space you are like taking in during the process as well.
Okay, got it.
So that's why it is order of 1. Okay.
Yeah.
Now let's go ahead. Selection sort.
I don't know.
You don't know selection sort?
No.
Okay.
So in sorting, I know only 1 or 2. I did not have time to check the other things. That's why I asked you to tell me. Merge sort. So insertion sort is like select or assuming the first one is the smallest, right?
Which selection sort or insertion sort?
Session.
Selection sort. Yeah. See this one. So this is the example of selection sort. Okay, fine. So what is happening? This is 20, 12, 10, 15 and 2 array, right? So
Yeah.
what it will try to do, it will try to find the minimum value at index 1. Okay. Then it will increment the I value. It will try to find the minimum value in those two. Then it is going to come here. It is trying to find the minimum value in here. And then it is going to come after iteration 3. It is going to try to find the minimum value in here as well. Okay.
Yeah, and then
And then,
compare it to the first
correct.
one.
Now this is happening only for one value.
So we'll not be swapping, we'll just compare and
Yeah,
go until n, and then we swap if we find any minimum number at the last.
correct.
Okay.
Okay, fine.
Yeah.
Now tell me, according to this, what is the space and time complexity?
So it is again O of n square, right?
Correct,
Will
very
be
good.
space is O of n.
Of 1.
Sorry. O of 1. Yeah. I
Okay,
had O of 1 in my mind and I said O of n. O of 1.
yeah. Okay, now tell me what the insertion sort.
So in insertion sort, we assume the first one is always small.
Mm-hmm.
And we'll keep going and we'll keep swapping. That is the difference between selection and insertion sort.
So
Right?
as a pivot, you are saying?
Yeah, pivot.
Okay, but still the time and the space complexity is same in this case as well. Insertion sort, right?
Yeah, it is also O of n square.
Yeah. Then comes the powerful sorting algorithms, that is the merge and the quick sort. Okay. Now, you have idea about merge sort? No? Okay.
Do you partition and then
Correct. And then merging.
sort and then merge it? So mostly we'll be using merge sort.
Yes. Merge and quick sort. And again, it depends upon situation to situation. I'll tell you where. Okay. So
And I
this is
see they use lot bucket sort everywhere. And so I was going through one of the videos. They told me that you need to know about radix sort and bucket sort because they are non-conventional and they are not used much, but they are very efficient.
they're very efficient. And one more one more extra is there, heap sort.
Yeah, heap sort. Yeah.
Heap sort is
Oh,
very,
I didn't do anything with heap.
but it is also very efficient.
Yeah, heap is also very important, but I didn't do anything. Okay, let's see. My
Now,
interview is
this is
I have some time, but
at
so
least you just go through with the process.
just
Don't,
basic. Yeah.
yeah, just don't write the code and all right now because that is just going to waste the time because tomorrow you're having interview, right? Just
Yeah.
go through from all the topics like this only because your mind is good in that. That if you are gonna go through the topics now, you can easily convert that into the program. So that is fine with you.
I think so. Yeah, at least I need to show something that I can code, even if
Correct.
I'm not able to complete. That's my goal for now.
Correct. Correct. It should be, right? So that's why I'm saying that just go through from the revision point of view today till tomorrow.
Yeah.
Okay. And just let me know that how the interview went.
Yeah, definitely. Yeah.
Okay. Now this is the merge sort. Now see what is happening. First of all, it is going to take the like mid value. Okay. And then it is going to divide the array accordingly after taking the mid value. Fine. Then again,
Yeah.
for the left and for the right, it is again going to put the find the mid value and divide the array again into left and right side. Here as well, left and right array, it is going to divide. So basically what is happening till the end, they are going to get all the individual values here. Okay, they are going to divide again and again into left and right.
Yeah,
One.
divide and conquer. Yeah.
Yeah, right. After that, then they are going to get this one. Okay, then they are going to compare this and then merge. Then they are going to compare these two and merge and these two. And if it is single element and it is gonna come as it is, then they are going to combine these two and compare. Combine these two and compare, then again combine these two and compare. And that's how the merge sort is basically gonna work. Okay. Now tell me what approach you will use in terms of code.
So yeah, first we need to find the length and divide it by 2. Put both in different arrays. So we can use recursion, right? Here.
Correct. We are going to use recursion, but recursion of like for how many functions? Because we are
Yeah,
always
you will be sending left side array, right side array, and just write one method and compare and then swap.
I think two recursions
And
are
at
going to
the
be
end,
here.
you need to just concatenate left and right array.
No, I think two recursions are still going to be here, isn't it?
Yeah, first one is to divide the array.
Left side. Left and right. Continuously you have to call the left and right side of array.
Okay.
Okay, fine. Now tell me about the space and the time complexity.
So this we are using recursion and still it will be O of n square, right? If we are using recursion.
Think again.
But we are anyway dividing it, so it can be first we are taking n number of elements and then we are dividing it, so it will keep decreasing.
Correct.
So it's n log n.
Very good. Yes, it is n log n.
But in recursion, it is mostly O of n square because we'll be calling the method.
Yeah,
But
we
based
are
on the
method
elements,
only.
like how we are reducing the elements, it will change.
See, at least for this merge sort, you are traversing all the n elements, right?
Yeah.
So that's why the order of n is gonna come for that part only, right?
Okay.
Okay, and after that, the log n is gonna come when you are start going to merge, because at that point you're not going to traverse each and every element again. So that's why for the again part, the n again one more n is not there. Okay, just the log n, because the division part is happening. Log n is for the division part and n is for traversing all the elements. So that's why n log n.
Okay.
Okay, and the space complexity?
O of n?
Yes, it
O
is
of n.
correct. Okay, because we are dividing each and everything. Everything is basically now taking their own spaces, right?
Yeah.
That's why. Okay.
Okay.
Now tell me about the quick sort.
I don't know. I don't know. You don't ask me like other sorting. I don't know. I mean, I have studied, but I don't remember now. I did not do it now.
Okay, now see this one.
Mm-hmm.
The quick sort is also going to take the pivot element. Okay.
Okay, but
Then that pivot element is now, in that pivot element is
how do
now,
you choose pivot?
it depends upon you. It doesn't have to be like the last one. It doesn't have to be the first first one. You can either take this one as a pivot, this as a pivot, and the medium value as a pivot as well. Because on the basis of that only you are going to do the sorting. How? Let's say that you are taking this last element as a pivot. Okay. Then you are going to put this one in the middle, and then you are going to start sorting the things. Then you are going to sort in such a way so that all the elements in this which are lesser than 3 are going to put them in left side,
Left?
and all the elements which are greater than this you are going to put in that side. Okay. Now again, it might be the possibility that this array is not sorted. Again, you are going to choose the pivot element, because now at the start you have chosen the last one, so it should always be the last one. Again, you're going to put one here, and then you're going to sort according to the left and right side. Okay, so till the end, it is always going to give you the sorted array. Got
Okay.
the process?
Yeah. Yeah, this is
Okay,
similar to merge sort, right?
almost.
Yeah.
Okay,
So again, we are dividing it. So
correct. Okay, so now the time complexity
yeah, O of n log n.
and space.
Space is O of n.
No, think again. Let me show you the diagram.
Okay, we are not taking any extra space. We are just manipulating the existing array. So that will be O of 1.
Think again.
No. Mm,
Okay, I am telling you it is log n. Now tell me why.
because you are dividing the space.
Because at each recursive call, the input array is divided into 2 partitions, right? The recursion continues on the smaller partition only.
Okay.
Okay, the recursion is always going to be in the smaller partitions only, not for
Okay.
each and every one, right? So at each level of recursion, a constant amount of space is used to store variables and function calls information. So that's where it is going to take log n.
Okay.
Okay, but that is the average case. There are always the worst case, average case, and the worst case, correct?
Yeah.
In the worst case, it is always going to take order of n.
And time complexity will be n square for everything.
Yeah, and why this is happening? Because when you're continuously selecting the smallest or the largest element as a pivot,
Mm-hmm.
right? In that case, it can worse, correct?
Okay. Yeah.
Okay. Now merge sort and quick sort, both of them are like almost same, correct? In terms of space and time complexity. Which
Yeah.
one should we choose?
quick sort because we are using less space.
Okay. Can you give me under any scenario?
No idea.
Okay. So, let's say you have large number of elements in an array, right?
Hmm.
In that case, it doesn't matter that which one you're going to choose. No, it is again going to matter depending
Hmm.
upon the pivot. Then in
Okay.
that case, you're always going to choose the quick sort, right?
Yeah.
Okay. Merge sort is gonna guarantee you order of n log n time complexity in all the cases. Okay. However, if the input data is expected to be random or even if it's the worst, right? Quicksort's average case time complexity may change from n log n to other cases as well. So it is not quicksort is never going to give you guarantee, because it is also it can be worst even if you have chosen the pivot very wrongly, isn't it?
Hmm.
Right? Again, the
Yeah.
iteration number of iterations are going to increase, so it is going to fluctuate at that point of time. But for merge sort, it is always going to give you guarantee of n log n. It is never going to change for that, because there
Okay.
is not even the tiniest scope of doing something different. Here we have the highest probability as well that we are choosing, let's say, ninth one as the pivot element. Correct?
Yeah.
So number of iterations can increase. So for longer arrays, we generally use merge sort.
Okay.
Okay. And in terms of stability as well, that is the thing that you can say that in terms of stability, merge sort is more preferable. Okay. And in terms of space constraint, if you have limited memory space and like you cannot have additional space at all, right? Then quicksort is of course the better choice.
Okay.
Fine. But you're never going to find a proper answer that what to choose and when to choose. Okay.
Okay.
Now let me talk about, okay, next is the heap sort and radix sort and bubble sort. Okay, no idea about the radix sort as well?
Yes.
Okay, so radix sort is basically going to sort the algorithm, entire array. Let me show you. Hmm. See, okay, it is also going to work in the form of passes. But in radix sort, it is going to sort elements based on the individual digits or characters. Like in 802, it is just taking 2, right?
Yeah.
Got it. So if there are 3 digits number, it is basically gonna work, let's say, for the last one at first. Then it is gonna work for the first one, this one. Okay, then it is gonna come for this one. This is how the radix sort is going to work.
Okay.
You are seeing this term LSD. Okay, so it starts this LSD sorting algorithm. There are 2 types of sorting algorithms. One is on the basis of LSD. One is on the basis of MSD. Okay, LSD means least significant digit and MSD is most significant digit. So let me tell you, in LSD, it starts sorting from the least significant digits and move towards the most significant. Let me think of an example. Let's say, let's think of this example only. Okay, in the least significant digit, wait, let me remove this. Okay, what is happening? In the first one, in the last digit, okay, what it is going to see, that which one has no, like, very less botheration. That means on the basis of 0, it is gonna start working on the last one, last row, sorry, column. Okay, then again it is gonna come here, then again it is gonna look for the least value. Least value means you can say the smaller number. Okay, and then it is going to come here again, and again it is going to work for the smaller number. Are you getting it, Abhinaya?
You will be comparing the digits,
Digits only, yeah.
not the whole number.
No. So that's why they have, see, the high.
Still, if we are comparing, right? Then
We are comparing, but this approach is different.
okay.
Just think about it. That what do you think this approach is going to give you the complexity? But did you get the process?
Hmm, So, okay, if it has more digit, then we'll just be moving it.
Mm-hmm.
It's like that.
Moving it as in?
Check again. Let's say I have one digit and two digit.
Mm-hmm.
So how do you compare these two?
Like this. This is a perfect example. This is having three digits, and this is having one digit only, correct?
Yes.
Okay. So see what is happening. In that case, it is imposing 0, 0, 0 in front of it.
Okay.
Okay. So that's why they're gonna come, like, see, let's say you are having these two elements only. So at first, it doesn't matter that whether you are having 3 or 4, because it is always going to compare the last one,
Hmm.
right? When it is done with the
So
comparison
if
for the last
it's
one,
so now it is both two.
sorry.
Uh, now it has two, like both of the numbers.
Yes. So now there is nothing it will do, right? So then what it will do, it will jump towards this part. Now this part has 0, this part has nothing. So where it has nothing, what it will do, it will put 0 there again, and then it will compare.
Hmm.
Okay. Again nothing. Then again it will go here, nothing in here, 8 is here, so it will put 0. Now it is going to compare. Now it will see that 8 is greater than 0, right? Or 0 is less than 8. Then it is going to put this one above 802.
Okay.
Got it? Now this is the LSD part. Okay, now let's see the MSD part. Wait, let me see if they have the MSD part or not. Okay, till then, just think that what the time complexity is going to be.
This will also be like n log n.
Mm-hmm. No, I don't think so.
So how do we check the digit? Like how do we add it to the time complexity?
In time complexity, I think what I know so far is, let me check, wait. Because it is not very much in common practice to work with Redux sort.
Okay, then
See,
leave it. I'll not do it this time. I'll
no, but still, if sometimes they are asking a quick answer, na, you should have a like preparation for at least
Yeah, no,
one.
I know, like you'll be checking with the digits. That's fine. I don't want to get into this too much.
Okay,
We'll keep it simple now, for now.
okay. Then let's talk about the bucket sort in that case. Okay.
Yeah.
Okay, so bucket sort is basically divides the input into a number of buckets.
Hmm.
Wait, let me open this in this
And
example.
you put multiple numbers in.
Yeah. Okay. Each you
Range.
can see the range and the elements that are then distributed into these buckets based on their values. And each bucket is now going to be sorted because we are going to compare those values only with each other, right?
Hmm.
Okay. And then we are going to combine all these buckets with each other together. For example, this one. So what is happening in here? This is the array. Okay. So in between we have started putting all of them into the bucket. Okay, now see what is happening. Here the value ranges from 0 to 5. So the range is basically we are specifying 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. Right? Then in that way, after this, because we are only comparing 4 and 2, now the 4 and 2 is sorted. Okay, again here this one is sorted. Again here this one is sorted. This one is sorted and this one is sorted, right? Okay,
Yeah.
now all of them are sorted already and they're also in the range. So if they are in the range, they're already in the sorted form by the end, right? There is no like thinking twice that whether it is in the sorted form or not. Because the range you have specified, you are putting everything in the form of range, and then within that range only you are like doing the sorting all the elements, comparing with each other, and by default when they are going to come out of the bucket, or you can also use the term concatenation of the buckets with each other, they're always going to be in the sorted form.
Okay. So, when you say compare the buckets, what do you compare it with? All the numbers with all the
No,
numbers?
not compare the buckets in the sense ki in the bucket you have the numbers, compare the numbers within the bucket.
Inside the bucket.
Correct.
Okay.
Okay. When the like a comparison is done, then you can concat all the buckets with each other. So
Okay.
concatenation is going to give you this combined answer. Got it?
Yeah.
Tell me one thing.
So, but
Let
one
me put
bucket
you,
can have more elements and the other can have less elements.
yes, and one situation I'm going to put in, let's say that you are dividing the range in such a way. Let's say I'm going to divide it in the range of 25 to 30. Or in between we have one range. I'm gonna give you, this is 5 to 10, we have element 2, 4, 9, 6, right? In between, let's say I'm dividing the bucket on the range of 5 to 7 as well. 0 to 5, 5 to 7, 7 to 10. Then 5 to 7 doesn't have any bucket, any value in that, correct?
Yeah.
So that means we have to sort each non-empty bucket individually as well. We're going to look for them, right?
Mm-hmm.
Correct? Fine.
Yeah.
So that is also going to go and look for the empty bucket as well. So I think we should be very careful when we are creating the ranges. That's where the game is gonna start.
Okay.
Okay, according to this situation, what is the time complexity?
No, I'm not able to calculate. I can say space because we are using extra space. So it will be number of elements plus, let's say, like space, then it will be O of n plus m.
Out of n into n?
N plus m, space complexity. I'm not able to calculate time complexity.
Okay, so the time complexity for this one, if I'll talk about in the worst case, it is order of n square. When all the
Okay.
elements are placed into a single bucket only. That is the worst case, right? Okay, fine.
Yeah.
Let's in this situation, what is going to be the range? Let's say the range is from 0 to 25. There is only one bucket you have created. And let's say you have also created 25 to 50, and the other bucket has no element at all. So that is the worst case. So it is always going to be order of n square. In average case, where the number of elements in the input array are, let's say we have these number of elements, order of n, at least it is going to be there, because you're traversing through all the elements to put them into the same bucket of the range, right? Then after that, what it is going to do, it is also going to do the comparison for the number of elements present in those buckets, right?
Yes.
Okay, so it is always going to be, let's say n is the number of elements and b is the number of elements in the bucket. So it is always going to be n plus b.
Okay.
Okay, fine. And same goes for the space as well. N plus b. Okay.
Okay. Okay, we have only 7 minutes. Then
What time it is? 53. Let me quickly tell you the topics as well in your mind. I'll also be sending it to you on
Yeah.
the yeah. Okay. Okay. So in
So
linked list, you
yeah.
have like traversing, iteration, and recursive as well. You have how many types of linked lists available? Single, circular, and double, right?
Okay. So circular is also considered as a pattern. Okay. I
Yes.
thought that just check if a linked list has a cycle. Okay.
No, no, no. It is a proper
Okay.
like topic, circular linked list.
Okay.
Okay, where it is gonna go in the circle.
Mm-hmm.
Fine. So, and for all these topics, the very difficult one are to insert the data, because all of them, whether it is single, double, or circular, all of them are going to have the complexity, like traverse, insertion and deletion of the
Yeah,
data.
we'll have to
Middle one.
traverse. Yes. Yeah.
Yeah, for the middle one, you have to apply different logic if you want to insert any element. For the starting and for the ending, you have to apply other different logics. So the more work is there for the insertion and deletion part. That means insertion at the beginning, at the end, and then at a specific position. And same goes for the deletion as well.
So if it is at a specific position,
Mhm.
how will they ask? Like in the middle or anything? So that time what we need to do is we will have to traverse until middle, and we need both previous and next. So there we will be
Correct.
inserting our new node. We don't need the next pointer because our current will become the next if we are
Next
inserting it
pointer.
before. So the previous dot next will be our value that we are inserting. Our
Mhm.
value dot next will be my current. That's it.
Correct. At a specific position. See, this is how it is
Yeah.
going to happen.
Yeah. Yeah.
You have
This
to break the
list I
link and
practiced. Yeah.
yeah. Okay. Right.
Yeah.
And then one algorithm that is very famous.
Reverse in linked list, and then
One is Floyd cycle detection algorithm.
oh no, I don't want to do anything new now.
Okay, okay, leave it then.
Floyd, right? I will maybe check,
Yeah, yeah.
but I doubt if they are going to ask all of these
Okay,
things.
okay. In binary search, very commonly that they can ask is in order, pre-order, and post-order traversal. You must have heard of these,
Yeah, I know.
right? So in traversal, they are going to talk about this. And very famous questions that
So,
what is the height of
what
the
is the difference you said between binary search tree and binary tree?
binary and binary search tree? In binary search tree, it is always going to be the root value, the left side is always going to have lesser elements than the root, and the right side is always having the greater elements than the root.
Greater than the root. Yes.
Correct.
Okay.
That is the binary search tree. In binary tree, it can be anything.
Okay.
Okay. And the very famous question that they always ask: height of the tree, depth of the tree, the complexity. These questions are their favorite questions in binary, whether it
Okay.
is binary search tree or like binary tree only.
Then
Okay.
then find the last node, something like that.
Height, depth, and width as well.
Okay.
Okay. And let's not go into then AVL and red black tree. Have you worked on those?
No.
Okay, let's forget about it then. Okay. I
I don't know what is greedy algorithm. I wanted to read about it, but I meant to.
there are so
But
many great
I don't
algorithms
think. Yeah, I
from
cannot do it. Yeah, I will take time. It's okay.
no,
I'll go one
just
by
get the
one.
name only. If they are gonna ask that what type of algorithms are
What
there.
is? Yeah.
Yeah. Right. Greedy algorithm is there. Kruskal algorithm is also there. Okay,
Okay.
Prime's algorithm is also there. Prime's what I don't know what the exact pronunciation for that.
I
Okay.
only know Dijkstra's shortest path.
Shortest path only. Okay, fine. Minimum spanning tree is also there.
Okay, that is AVL.
I think so.
We
Right?
can also now I was checking a question like palindrome, but it's a medium palindrome question. So you will have to find the substring of that string that is a palindrome. So they're actually using tree. They'll
Okay.
be putting the string using tree data structure.
See, if it is for the substring, then yes, they can. But if for an entire word they are going to ask, then I don't think so the tree is required there.
No, not for entire array.
But for the sub
That
part
is
only.
easy question. I am saying if, let's say AAB, okay, in this you can have A as one, then A as another substring that is a palindrome, AB as another substring that is a palindrome. You need
Got
to
it,
return like,
subsets.
yeah, subsets.
Then in that case, the second one is going to be the palindrome.
Yeah, what
Yes,
questions
this
with
is.
string and array? You tell me like basic string and array.
As in?
Questions.
The string and array
frequently asked.
questions like these,
Yeah.
where there is a mixing of
Yeah.
trees as well. Okay.
No,
I'll
not
create.
mixing of tree, just frequently asked questions with arrays and strings.
Okay, the very frequent question that they ask with the array is adding the some numbers, adding the entire array. Okay.
Yeah.
In 1D as well as in
Sum
the
is also there. Yeah.
2D. Correct. Okay. Wait, let me think. Yeah, reverse the string and reverse the in string. It is always reverse the string. Okay, that is this very simple question that they can ask.
Anagram.
Anagram. Okay, and then for array, find the maximum, find the minimum number. Okay, check the palindrome there as well in the array. Fine.
Okay.
In the string, count the vowels and constants. Anagrams you've already said. Yeah, these are the basic questions that reverse a string and reverse a number, etc., etc.
Okay.
Okay.
Okay. I'll check GigaMe as well.
Yeah. You're not doing questions from there now?
I did. Like there are a few LeetCode questions as well. Then I was going through some JavaScript coding in questions.
One question just popped into my mind. String. That is longest
Common substring
sequence. Longest sequence.
without
In
right? That is yeah, I know
yes.
that.
Right? Okay,
Yeah,
so
that
that is
is
also very
sliding window. Looks like the Roman to integer we did. They have asked it for Roman to integer, integer to Roman.
yeah. Okay. All
That
the
I
best, Abhinaya. Okay. I hope that this
thanks.
is gonna go good for you. Okay, but just
I
don't
might.
come into pressure.
Yeah. I so my goal is to see if I'm able to code in JavaScript, if I'm able to do some basic thing now. I don't have something like, oh, I definitely need to pass this interview. No, I know my preparation level. So until this, because before 2 months, I would be like, no, I cannot code in JavaScript at all. But now I have come to that level, so I'll take it one by one. It's okay.
Yeah, because you're working hard, you're doing it continuously, right?
Yeah.
And if you're ever gonna go in the interview that you have to crack it, you're never gonna crack it. That is
Yeah.
always an applied method,
Yes.
right?
Yeah, it is another
Okay.
experience.
Yeah,
Yeah, I
you
may
let me
get
know
one
about it,
more.
okay?
Yeah, I may get one more interview. Let's see. That's with Boston Consulting Group. I don't know if you know that company.
I know that company. Many people are giving the interviews
Interview?
for this
Okay.
company as well.
Yeah, but she said I spoke to her only today, but it's for the internal team, not like client facing or anything. So let's see. And I also had a call with Meta Recruiter,
Okay,
but
good.
I just read on Reddit that they are freezing the hiring. But let's see. I told her I need some time. She also said you take some time. I'll get back to you after a month. Then we'll set up mock interview, etc.
Okay, cool.
Yeah,
Good.
I'll be getting something. I'll keep working on
Yeah,
mastering the basics first.
yeah, sure. Okay, Abhinaya,
Okay,
then
yeah.
I'll see you
Thank you
next
very
time,
much.
okay? Thank you.
Yeah.
Bye-bye. All the best. Bye.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.